The matrix A is of order 3 by 2, and the matrix B is of order 2 by 1. Write down the order of the resultant matrix AB. And so matrix A has the order 3 by 2. That's matrix A. And matrix B is of order 2 by 1. Now, notice that these two numbers here are the same, all right? And so that means that these two matrices, A and B, we can multiply them because multiplication is defined among them. That means that we are able to multiply them and get a result. But what is the resultant matrix that we're going to get? Well, the resultant matrix that we're going to get is we're going to get a matrix of order 3 by 1. So the resultant matrix will have the order 3 by 1. That's the order of the resultant matrix, 3 by 1. All right. And so that's the order of the resultant matrix, the order of the resultant matrix. We don't have enough to know what are going to be the entries, but the order of the resultant matrix is definitely 3 by 1. Okay, next we have this matrix equation, and our goal is to calculate or to determine the values of x and y. And so this is what we have. We have that equal to 10 and 5. Now notice these two matrices, right? Notice that the first matrix has order 2 by 2. That's the square matrix, all right? And the second matrix has order 2 by 1 because it has 2 rows and 1 column. And notice that these two are the same, so that means that multiplication is defined among these two matrices, and the resultant matrix would be a 2 by 1 matrix. Now, if it's a 2 by 1 matrix, what that means is that we'll have 2 rows, so row 1 and then row 2, all right, 2 rows, row 1, row 2, but we're only gonna have 1 column, so this is only gonna be column 1 and column 1, okay? And so that's what we have. So this right here is telling us the order of the resultant matrix when we multiply these two, all right? Again, this one is a square matrix. It has 2 rows and 2 columns, 1, 2. So that's why we have a 2 by 2. And this one is a 2 by 1 because it has 2 rows, 1, 2, and 1 column, 1. That's a 2 by 2. These two are equal. The resultant matrix is a 2 by 1 matrix. Row 1, column 1, row 2, column 1. And so this is going to be our formula to help us to multiply these two matrices. So the first thing we have to do, row 1, this is row 1, column 1, all right? So we're going to do row 1 multiplied by column 1. And so we have 5 times x, and we have 0 times y. That's why we have here 5 times x and 0 times y. Next, we have to do row 2, column 1. So row 2, column 1, row 2, column 1. So we have -1 times x, and we have 1 times y. And so that's what we have here. And this is equal to 10 and 5. Next, we multiply. What is 5 times x? 5 times x is 5x. 0 times y is 0. -1 times x is -1x. And 1 times y is 1y. We have that equal to 10 and 5. Next, what we do is we say 5x plus 0, and that's simply 5x. -1x is simply -x, and 1y is simply y, and we set that equal to 10, 5. Now, if two matrices are equal, then that means that their corresponding entries must be equal. And so if these two matrices are equal, that means that 5x must be equal to 10, okay? 5x must be equal to 10. And it also means that x plus y, -x plus y, is equal to 5. All right, so these are the two equations that we have, and we have to solve for x and y. In order to solve for x, what we have to do is we have to divide both sides of this equation by 5. We cancel this with that, and so we get that x is equal to 10 over 5, and so that means that x is equal to 2. Since we know that x is equal to 2, we're going to substitute that into this equation. And so we have that x is equal to 2, but we have a negative up front, so it's -2, plus y is equal to 5. We send the 5 over the equal sign, and this is a negative, it becomes a positive. So we have y is equal to 5 plus 2. And 5 plus 2 is definitely 7. So y is equal to 7. So x is equal to 2 and y is equal to 7. And that's our answer to this question.